Compounds of what? Starts with E. Compounds and elements. Very good, Kai. So those are the two groups that make up the substances, the compounds.
The tiny invisible particles or atoms. A Tom, no cut. If you cut and cut and cut and cut, the reason the process had to stop somewhere. If an object has infinitely many pieces, then everything would take forever, instead of only seeming that way. Gold seal between them. A valve allowed him to pump air out of the interior. When the sphere closed, a near vacuum force couldn't pull the two halves apart. Then he let the air back in, and the space two hemispheres separated easily. Explanation: air pressure on the outside.
In the beginning, we had the two substances were compounds and elements. We learned about the 5 separating mixtures. You got filtration. What else?
Sublimation, chromatography, whatever.
Crystallization.
And distillation.
Distillation. Very good. So up here, when you have your compound separated from your mixture, in order to separate into elements, you're going to have to do what's called a chemical change. This is a chemical change, taking water and breaking it down. So this is called a decomposition reaction. This is basic water. You might want to write this down if you didn't know it. Water breaks apart into hydrogen and oxygen. This is going to be the fuel of the future. The dollar will probably be tied to hydrogen in the future. Today it's tied to oil.
So like our cars get
Substances are composed of two groups. What are in the substances? Compounds and elements. Yes, write that down. Now, if you want to get a substance, typically you're going to do that out of a mixture. And there are 5 methods to separate a mixture. Does anybody remember the 5 methods? Should have seen a couple of those in biology. That's one of them, distillation. Aiden, good job, filtration. Those are the 2 easiest. Those are the ones people know the most about. We'll probably do a lab on the 3rd one this week, chromatography. And then there's crystallization. And what's the last one? Sublimation. So we'll read about those today. That's kind of a little bit of review. So before we do that, we want to look at this sheet right here. Part of your homework will be to color this, because I like coloring. So who wants to read first for us what says, what accounts for matter's secrets? Go ahead. So the question is, did Aristotle and Democritus get along with their thinking? And the answer is basically no, they had different views. So what were their different views? What did Aristotle view? Earth, fire, air, and water. I want to write that down. It's pretty important that you understand previous thinking. If you don't understand previous thinking, then everything gets a little confusing. So Aristotle, earth, fire, air, and water. Actually, that was Heraclitus. He was the one who came up with that. And then Aristotle added the 5th element, ether. Now, back to Democritus. Did they get along? No. What did Democritus think? So after you have Heraclitus, earth, fire, air, and water, Aristotle added the 5th element, ether, in your notes. You're going to write Democritus. So he's the next big thinker. What did he think? Made of atoms. Yeah, so if you see here, it said the atomists, led by Democritus, thought that matter was made out of tiny invisible particles called atoms. Now, did he think the atoms could be broken into 2? No, atom means what? No cut. Yeah, it says right here, it means atom means no cut, that you can't cut it. So, Was Democritus a believer in ex nihilo? No, he was a supporter of ex matria. So both of them were supporters of ex matria, both Democritus and Aristotle. My question is why? Why would they thought differently about the matter itself, but why did they support ex matria and not ex nihilo? Well, they have a little visual here. I love cartoons. You've got, I guess that's going to be Democritus there. It says, makes sense to me. So he's got his little umbrella and he's saying, makes sense to me. He could not make sense out of ex nihilo. Because you have no opposites. I mean, it goes back to if you've got somebody who's got a mental illness and you go tell them that they're just fine, they're going to argue with you that they're not just fine. You know, if you've got somebody who's really, really happy, you got somebody who's really, really sad, and you go to both of them, you say, you know, y'all are the same. You're going to be like, no, we're not the same. There's two different emotions. There's an emotion of happiness is very different than an emotion of sadness. So, you know, Aristotle, he understood these things, so did Democritus, and understood basically morals too. I mean, if you're going to do something right and wrong, I mean, science, you know, rests on morals as well. We try to figure out what is good and what is right so that we can protect ourselves from what? From war. People want to kill us. Yeah, if you don't think that they do, that's when you get surprised, Pearl Harbor. It happens. I mean, I was reading the other day in the news that we supported a coup against the president of Venezuela. I don't know whether that's true or not, but it was reported in the news. I mean, it happens. People want to overthrow our government. And if you're not looking out for the truth, I guess you're going to get surprised.
The most influenced medieval science. It was so optimistic. If everything is a mixture of four elements, then you should be able to turn anything into anything else just by tweaking the ingredients.
Yeah, so he had the most influence on medieval science. I think he was a good politician as well. He might have been handsome. Those things tend to work well if you're handsome and you have money. You tend to be able to convert people to your thinking. The biggest probably thing would be money. If you have good finances, you can just keep lobbying until everybody agrees with you. So he was able to do that. And that's the reason why you didn't see a lot from the atom until John Dalton comes along. It was still out there, but it just wasn't really supported. The thinking that was supported was that of Aristotle in the actual academic community. You have the academic community, then you have the, I guess you would say, theology community. And their thinking was not ex matria, it was ex nihilo, so they really weren't doing any type of research on that. They were just kind of agreeing with what other people were telling them. How about Kennedy? Why is separating mixtures important? We want to be able to separate mixtures because it has to do with substances. If you are making a new product and you have something called impurities, impurities would be mixtures which you don't want. Like if you're making a car battery and you have a mixture in your lead, that's going to be a problem when you sell the battery, because impurities will affect the charging time. This is true with your cell phone as well. So if you buy a cell phone and you're only getting like an hour charge with it, there's an impurity in the battery. You take it back and you say, I want a new battery. Now if you've had your cell phone for, let's say, 5 years and it's starting to not charge as long, yeah, you may have overheated the battery. If the battery heats up really, really hot, you can cause a new chemical reaction to occur and an impurity to develop. So it can move around. That's how it works. So overheating things, that's typically a problem. For example, if your battery dies and you get a car jump, somebody comes and jumps you. If the jumper cables cross, what happens? The alternator, which is charging the battery, causes the battery to heat up because the wires they spark. Have you ever seen like when wires cross, they spark out? That's what's basically happening in your battery. It's just heating up the battery, and when you do that, it kills the battery because there are impurities in there that have caused the battery now not to work. So if we're jumping the person's car that had a dead battery, now your battery's dead. Okay, so Aristotle, he's considered to be the father of what?
Matter.
What? No, he's the father of what? Starts with a B. Biology. We talked at the beginning of the year. Aristotle was the father of biology. Tony Lavoisier is the father of chemistry. So, and there's 3 people, Einstein, one of them, the father of physics. So Aristotle up here, he had some backing. Biology, he was working on life in there, and because of that, people agreed with him. He had some financial backing. He was doing things right. In order to be into like education, you got to do some things right to tell other people. It means you have to be making money. So he had some finances behind him. And that's why he was able to push his agenda and Democritus didn't. His thinking about the atom really didn't come about in a more scientific way until John Dalton came along and started examining it. So he was suppressed. Now his ideas were still out there, they were still being read about it, but Aristotle's were being dominated. They were definitely the most important that were being taught. So aether is this 5th element of like light and gravity, or what's happening out in space, that Aristotle proposed.
Titration, consider the advanced glassmaking, metallurgy, explosives, corrosives, and they invented fortified wine.
Okay, so chapter 3, we're just reviewing a little bit about the separating a mixture and the 5 methods, and they just read several of them to you. What's one method for separating a mixture? Distillation, another one. Filtration, another one. What? Titration. So there's several methods to do that. We'll read more of these in the that had to do with velocity and acceleration. So our objective is to understand the difference between the two. So who can help explain that?
Isn't velocity like displacement, the change in displacement over time, and acceleration is the change in velocity over time?
Right. So with acceleration, your time is changing. That is, you have a velocity and it's changing over time. That's acceleration. So in the handout that I just gave you, you're going to want to color that formula so that you're aware of it. Where you see acceleration, it says A equals V over T. That's the basic formula. That's the most basic that you can get. The 20 that we had on our test, that's where it's getting a little bit more refined. You can refine the formula, or you can make it really, really basic. So the really basic velocity formula is what? Yes, it has to do with time. So that the formula for time equals distance divided by velocity. So that's the velocity formula that you need to memorize that's on this paper. You can see velocity right here. Distance equals velocity times time. Then you're just going to algebraically solve for velocity. Everybody clear how acceleration is associated with velocities change over time? If you jump off the Golden Gate Bridge, if you go online and you're trying to calculate the G's, you're going to feel if you hit the water, they won't tell you this. And the reason is it has to do with how you land, as far as how long it takes you to stop. So if you stop really quickly, you're going to experience what?
Less G's.
Greater G's. If it takes you longer to slow down, you're going to experience what? Less G's.
So it
All right.
depends on your acceleration.
Depends on how you hit the water. You stop after 1 second, you're going to be experiencing around 1.7 G's. What does that mean? Raise your hand. What does that mean?
It's just 1.7 times 9.8.
No, it means 1.7 times what?
It means you're feeling 1.7 times the normal like gravity pulling for not that. I mean, you're feeling like I don't know how to explain it. Your body is 1.7 times. Yeah.
Matt is correct. You're multiplying that number, Isabella. You're multiplying your body mass times 1.7. That's what you're going to be feeling like. You're not. This is normal right here.
So basically, it's like your weight is basically how much gravity is pulling you. So it is.
You're going to feel 1.7 times heavier is what it amounts to. You're going to be feeling a lot different at 1.7 than you are at 1.
Because he has a greater surface area.
The greater surface area is going to cause them to stop a lot faster. So we're going to have to change our stop time here from 1 second to, let's just say, 0.1 second. So let's see what the difference is as far as the g-forces is going to